After ejaculation during intercourse, millions of sperm enter the vagina and begin an incredible journey. From the acidic environment of the vagina, only the strongest survive to swim toward the cervix, which is usually closed except during ovulation. Around ovulation, the cervical mucus thins and becomes more welcoming, helping sperm pass through this barrier. Once past the cervix, the sperm continue their challenging swim through the uterus. Muscular contractions in the uterus help propel them upward toward the fallopian tubes. Along the way, many sperm are lost or destroyed by the female immune system, drastically reducing their numbers. Finally, sperm reach the fallopian tubes. Only a few thousand of the millions that started the journey arrive here. They must swim against the natural movement of tiny cilia that push the egg toward the uterus, making their final approach difficult. Chemical signals from the egg and reproductive tract help guide the sperm, boosting their swimming ability in a process called capacitation, turning them hyperactive and ready for fertilization. In just minutes to a few days, depending on timing, sperm may meet the waiting egg in the fallopian tube. But remember, sperm can survive inside the female reproductive tract for up to 5 days, patiently waiting for the perfect timing. The moment of fertilization usually happens in a specific part of the fallopian tube called the ampulla, which is the outer third near the ovary. The mature egg is surrounded by protective layers, including a group of cells called the corona radiata and a tough outer shell called the zona pellucida. As sperm arrive, they are attracted by chemical signals from the egg and surrounding cells, guiding them towards their target. But not every sperm can fertilize the egg. First, the sperm must undergo a crucial process called capacitation, changes that increase their motility and prepare them to penetrate the egg's defenses. Once ready, a sperm binds to the corona radiata and starts breaking through this layer with enzymes. Then it must penetrate the zona pellucida, which is like a protective gate. The sperm triggers an enzymatic reaction called the acrosome reaction, releasing enzymes that digest the zona pellucida to allow the sperm to enter. When one lucky sperm finally penetrates the egg membrane, the egg immediately reacts to block other sperm from entering, ensuring only one sperm fertilizes the egg. This process is essential for healthy development, preventing what's called polyspermy. In this moment, the sperm's nucleus enters the egg and fuses with the egg's nucleus, combining genetic material from both parents. This fusion creates a single cell, the fertilized egg or zygote, with a complete set of 46 chromosomes. Fertilization itself happens within minutes once sperm meet egg, making it a rapid yet incredibly complex event. As soon as the fertilized egg, now called the zygote, forms, it embarks on a rapid process of division called cleavage. During cleavage, the zygote divides many times without growing in size, producing smaller and smaller cells called blastomeres. Within the first 3 to 4 days, these divisions create a solid ball of cells known as the morula, typically made of about 16 cells. This morula then begins to develop a fluid-filled cavity inside, transforming into what is called a blastocyst by around day 5. The blastocyst consists of an outer layer of cells, which will later form the placenta, and an inner cell mass, which will develop into the embryo itself. Through these early stages of division and differentiation, the tiny cluster of cells prepares for the next critical